5.715.6 kN citation jet, citation M2. P&WCPW 51993 3.901.52 M 0.70 M 0.28 T 13.3 kN citation XL, Phenom 300. GEHHF 122009 4.431.12 M 0.54 M 0.18 T 7.4 kN Honda Jet. Williams FJ 33 1998 0.98 M 0.53 M 0.14 T 6.7 kN Cirrus SF50. P&WCPW 600 2001 1.82.8 0.67 M 0.36 M 0.15 T 6.0 kN citation Mustang, Eclipse 500, Phenom 100. PS 90 1992 4.44.96 M 1.9 M 2.95 T 157171 KN IL 76, IL 96, 204. Powerjet Sun 146 2008 44.13.59 M 1.22 M 2.260 T 71.679.2 kN Sukhoi Superjet 100. Extreme Bypass Jet Engines, edit. In the 1970s, Rolls-Royce /Snecma tested AM45 SD02 turbofan fitted with variable pitch fan blades to improve handling at ultra-low fan pressure ratios and to provide thrust reverse down to zero aircraft speed. The engine was aimed at ultra-quiet still aircraft operating from city center airports. In a bid for increased efficiency with speed, a development of the turbofan and turboprop known as a propfan engine was created that had an unducted fan. The fan blades are situated outside of the duct, so that it appears like a turboprop with wide scimitar-like blades. Both General Electric and Pratt & Whitney /Allison demonstrated propfan engines in the 1980s. Excessive cabin noise and relatively cheap jet fuel prevented the engines being put into service. The Progress D-27 propfan, developed in the USSR, was the only propfan engine equipped on a production aircraft. Terminology, edit. Afterburner. Jet pipe equipped for afterburning. Augmenter. Afterburner for turbofan with burning in hot and cold flows. Bypass. That part of the engine is distinct from the core in terms of components and airflow, that part of fan blading, fan outer, and stators which pass bypass air, bypass duct, bypass nozzle. Bypass ratio. Bypass air mass flow /core air mass flow. Core. That part of the engine is distinct from the bypass in terms of components and airflow, core cowl, core nozzle, core airflow and associated machinery, combustor and fuel system. Core power. Also known as available energy or gas horsepower. It is used to measure the theoretical, isentropic expansion, shaft work available from a gas generator or core by expanding hot, high-pressure gas to ambient pressure. Since the power depends on the pressure and temperature of the gas, and the ambient pressure, a related figure of merit for thrust-producing engines is one which measures the thrust-producing potential from hot, high-pressure gas and known as stream thrust. It is obtained by calculating the velocity obtained with isentropic expansion to atmospheric pressure. The significance of the thrust obtained appears when multiplied by the aircraft velocity to give the thrust work. The thrust work which is potentially available is far less than the gas horsepower due to the increasing waste in the exhaust kinetic energy with increasing pressure and temperature before expansion to atmospheric pressure. The two are related by the propulsive efficiency, a measure of the energy wasted as a result of producing a force, i.e. thrust, in a fluid by increasing the speed, i.e. momentum, of the fluid. Dry. Engine ratings /throttle lever positions below afterburning selection. EGT. Exhaust gas temperature. EPR. Engine pressure ratio. Fan. Turbofan LP compressor. Fanjet. Turbofan or aircraft powered by turbofan, colloquial. Fan pressure ratio. Fan outlet total pressure /fan inlet total pressure. Flex temp. At reduced takeoff weights, commercial aircraft can use reduced thrust, which increases engine life and reduces maintenance costs. Flex temperature is a higher than actual outside air temperature, OAT, which is input to the engine monitoring computer to achieve the required reduced thrust, also known as assumed temperature thrust reduction. Gas generator. That part of the engine core which provides the hot, high-pressure gas for fan-driving turbines, turbofan, for propelling nozzles, turbojet, for propeller and rotor-driving turbines, turboprop and turboshaft, for industrial and marine power turbines. HP. High pressure. Intake ram drag. Loss in momentum of engine stream tube from free stream to intake entrance, i.e. amount of energy imparted to air required to accelerate air from a stationary atmosphere to aircraft speed. IEPR. Integrated engine pressure ratio. IP. Intermediate pressure. LP. Low pressure. Net thrust. Nozzle thrust in stationary air. Gross thrust. Engine stream tube ram drag. Loss in momentum from free stream to intake entrance, i.e. amount of energy imparted to air required to accelerate air from a stationary atmosphere to aircraft speed. This is the thrust acting on the airframe. Overall pressure ratio. Combustor inlet total pressure / intake delivery total pressure. Overall efficiency. Thermal efficiency * propulsive efficiency. Propulsive efficiency. Propulsive power / rate of production of propulsive kinetic energy. Maximum propulsive efficiency occurs when jet velocity equals flight velocity, which implies zero net thrust. Specific fuel consumption, SFC. Total fuel flow / net thrust, proportional to flight velocity / overall thermal efficiency. Spooling up. Increase in RPM, colloquial. Spooling down. Decrease in RPM, colloquial. Stage loading. For a turbine, the purpose of which is to produce power, the loading is an indicator of power developed per pound / sec of gas, specific power. A turbine stage turns the gas from an axial direction and speeds it up, in the nozzle guide vanes. To turn the rotor most effectively, rotor blades must produce high lift, the proviso being that this is done efficiently, i.e. with acceptable losses. For a compressor stage, the purpose of which is to produce a pressure rise, a diffusion process is used. How much diffusion may be allowed, and pressure rise obtained, before unacceptable flow separation occurs, i.e. losses, may be regarded as a loading limit. Static pressure. Pressure of the fluid which is associated not with its motion but with its state, or, alternatively, pressure due to the random motion of the fluid molecules that would be felt or measured if moving with the flow. Specific thrust. Net thrust / intake airflow. Thermal efficiency. Rate of production of propulsive kinetic energy / fuel power. Total fuel flow. Combustor, plus any afterburner, fuel flow rate, for example, pound / s or g / s. Total pressure. Static pressure plus kinetic energy turn. Turbine rotor inlet temperature. Maximum cycle temperature, i.e. temperature at which work transfer takes place. See also, edit. 1 axial fan design. 2 gas turbine. 3 turbine engine failure. 4 variable cycle engine. References.